Now, power function. Power function is the guy who is really literally the controller. You look at the front of the bus, which is the power function. Remember I said A tells you quite a bit. It gives you vertical, stretch, shrink, and it gives you reflect. So this guy is really in control of something that we call the end behavior, how this function is going to act like in the end. And what the power function is, when you come right down to it, it's the leading term. That's what the power function is. It tells you the degree, it tells you vertical, stretch, shrink, whether it's narrower or whether it's wider. It tells you whether it's reflect the x-axis. And why is it important to us? Well, it's the leading term. It's the highest power, and this is where we're on the edge of calculus right here. I'm now doing some hand waving, is what it's called, because we don't have the calculus terms. For large values of x, controls the end behavior of the polynomial. For large values, that means plus and minus infinity. When I think of end behavior really are the arrows at the ends of the graph. It's the arrows at the ends of the graph. Now, in the polynomial world, since you are dealing with just the integers, integers come in flavors even or odd. An even integer or even degrees behave in one manner at the end, and odd degrees behave in a different manner at the end. The representative of the even and the odd functions are x squared and x cubed. If you remember x squared and x cubed, you got end behavior down, because if the degree of the polynomial was odd, the arrows at the end acts like x squared or minus x squared. And if it's even, if it's even, it's x squared. If it's odd, then it's x cubed or minus x cubed. If you just remember those two, and behavior's piece of cake on polynomials. If I look at x squared, we'd have 0, 0, 1, 1, 1, negative 1. It's a bowl, and it opens up. End behavior is the arrows. This one says as x goes to infinity, and I could write it that way, x goes to infinity, y goes where? I follow y, it's going to infinity. Y goes to, that's that arrow, infinity, up. And as x goes to negative infinity, where does y go? Take a look.
Negative infinity.
Take a look.
Oh, infinity.
Infinity. Now I take the easy way out. I know that for a even degree polynomial, this is what we're looking at. Leading coefficient happens to be positive. So this guy says it's in from the top of the graph. It's going to do its thing, whatever it is, and it's going to be out through the top of the graph. So to me, when I look at this, the end behavior is top, top. In from the top, out the top. The arrows are going this direction, so reaching for the sky. Now, if I look at minus x squared, that's what I notice. Now, if I'm looking at the arrows, as x goes to positive infinity, where's y go? Negative infinity. And as x goes to negative infinity, where does y go? Negative infinity. So it's negative infinity, but to me, again, we're going this direction. At the end, I don't care what it does in the middle, I care what it does on the end. So for me, this is it in from the bottom, out through the bottom. So it's bottom, 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 bottom. Same direction. Now, what determines whether it's top, top, or bottom, bottom is the leading coefficient being negative. A is negative, it is reflected across the x-axis. It's your transformation. So even degree goes the same direction. It's either top, top, or bottom, bottom. Top, top if the leading coefficient is positive, bottom, bottom if the leading coefficient is negative. Think, oh, you're going down, down is negative, oh, not a good thing. Up, going to heaven, yeah, positive. Going down there, negative. Positive thing, negative thing. Or maybe more fun down there, I don't know. I don't want to find out, quite honestly. Now that's your even degree polynomial. Odd degree polynomial. Odd degree polynomial is represented by x cubed. X cubed kind of looks like a little S curve. So it looks like this. So I notice that as x goes to infinity, where's y going? Positive infinity. And as x goes to negative infinity, where's y going? Negative infinity. Now, and I look at this is in from the bottom as I'm moving from left to right, and out through the top. So this guy is bottom, top. Minus x cubed flips around the x-axis. So that means I'm now looking at this guy. He's harder to graph.
You can do it.
So there's my S curve. Now I notice that as x goes to infinity, y goes to where? Negative infinity, because he's going down. And as x goes to negative infinity, y goes to positive infinity. So if I look, he is in from the top and out through the bottom. So he is top, bottom. Now, you might think this is going to be hard to remember, but it really isn't, because even degree polynomials go the same direction if you think x cubed. So top, top, or bottom, bottom. So positive versus negative. Now, odd degree polynomials, now, you say, wait a minute, how do I remember bottom, top, top, bottom? If the coefficient of x cubed is positive, it starts from the bottom, goes to the top. BT is alphabetical order. Bottom, top. But if I put a negative inside, it reverses everything. It's reverse alphabetical order. So it'd be top, bottom. So if there's a minus in front, it flips it. If it's a positive in front, then you're looking at bottom, top. The other thing that I remember is this. If I have an odd degree polynomial, what letter does odd begin with? O. What letter does opposite begin with? O. So odd is opposite. Which means if odd is opposite, then even has to be the same. Because they're either the same or they're opposite. So if odd is opposite, then even has to be the same. So that's kind of how I remember it. Bottom, top, top, bottom. Negative is going to make the difference as to what's going to happen. That's the purpose of the power function. He's the controller. He basically controls what happens in the end. He controls what happens in the end. End behavior.